Hello everyone and welcome back to my channel. Today, we have an exciting contents for you. If you're new here, don't forget to hit that subscribe button and ring the notification bell so you never miss out on our latest content. Let's get started.
In the name of Allah, the most merciful, the most beneficent.
Today, I am going to present Chapter 1, Real Numbers, Exercise 1.2. In this video, we will explore the concept of following topics: radical and radicands, definition of nth root, properties of radicals, reducing the index, base and exponent, rational exponents, their definition and properties, and their importance in mathematics. Let's begin. Today I will be discussing an important mathematical concept, radicals and radicands. To begin with, let's talk about the square root. A square root of a positive number is another number that, when squared, gives the original number. For example, the square root of 16 is 4, because square of 4 is equal to 16. However, it is important to note that any positive number has two square roots, which are additive inverses of each other. In this case, the other square root of 16 is -4, because square of -4 is equal to 16. Now, moving on to the principal square root. This refers to only the positive square root of a number. For example, the principal square root of 25 is 5, written as square root of 25 is equal to 5. The symbol is called a radical sign. And the number 25 under the radical sign is called the radicand. This concept is crucial in algebra and real number operations. Now, let's start definition of nth root. For any real numbers a and b and any positive integer n is greater than 1 if a raised to the power n equals b, then a equals b raised to the power of 1 over a, where n is the index of the radical. We read this mathematical equation as b is the nth power of a, and this mathematical equation as a is the nth root of b. In example 5, the table shows three examples of radical expressions. The first column represents the radical form, the second column shows the index of the radical, and the third column identifies the radicand. For example, in the first row, we have the cube root of 35. Here, the radical index is 3, and the radicand is 35. Similarly, the second example shows the fifth root of the fraction xy over z, where the index is 5 and the radicand is xy over z. The last example is the square root of minus power of xyz is 4, where the index is 2, and the radicand is minus power of xyz is 4. Now we will discuss the properties of radicals, specifically the product and quotient rules for radicals. Explaining the product rule. The product rule states that the nth root of a multiplied by the nth root of a is equal to the nth root of the product ab. For example, the cube root of 8 multiplied by the cube root of 27 is equal to the cube root of 8 multiply 27. Explaining the quotient rule. Similarly, the quotient rule states that the nth root of a fraction a over b can be expressed as the quotient of the nth roots of a and b separately. For example, the cube root of 64 divided by the cube root of 8 can be rewritten as the cube root of 64 over 8. These rules help simplify radical expressions and make complex calculations easier. Understanding them is essential for solving radical equations efficiently. Now let's define reducing the index. If the index of the radical and the exponent of the radicand have a common factor, the expression can be written with a smaller index. Now we will learn about exponents and their role in representing repeated multiplication. Understanding base and exponent. An exponent tells us how many times a number, called the base, is multiplied by itself. For example, in the expression 3 multiply 3 multiply 3 multiply 3, we can write it in exponent form as 3 to the 4th power. Here, 3 is the base, and 4 is the exponent. History fact. Did you know? René Descartes, 1596–1650, was the first mathematician to use exponents in the way we do today. Key fact: explain the box at the top. When the exponent is a natural number, the base can be any real number. We use an exponent as a convenient way to write repeated multiplication. Properties of exponents. If m and n are rational numbers, then for non-zero real numbers a and b for which the expressions are defined, the following are the properties of exponents. First one is product rule. Second one is quotient rule. Third one is negative exponent rule. Fourth one is power of a power rule. Fifth one is power of a product rule. Sixth one is power of a quotient rule. And seventh is negative power of a quotient rule. Thank you.
Thanks for watching this video, and don't forget to like this video, click on the subscribe button for more update, and let us give your opinion on video in the comments section below.